you. Hi, folks. Hello, I'm Abdel. I'm actually based out of Sweden, Stockholm. I work for Google in the office there, but right now I'm joining remotely because I'm in Morocco, chasing some sun. And I'm going to tell you why your application is not cloud native. I joined the last 10 minutes of Rustam talks, so he did already a lot of heavy lifting on the stuff I will talk about, but I'm here to tell you why the 5 things that would indicate that your application is not as cloud native as you think it is. Before I get started, I just like to give a little disclaimer. Everything I'm going to share in this presentation is the pure creation of my own brain based on experiences I had. This doesn't engage my employer or the people I work with. These are my opinions and my opinions only. So just take whatever I'm going to say here with a grain of salt. And as Rustam said, I am happy to debate and argue after the talk or on Twitter. So let's get started with some facts. The facts are software is changing. We are having an explosion, if we dare to say, of new platforms and new ways of building and running software today. There are a lot of cloud platforms. There are a lot of tooling that are getting really popular: Kubernetes, Docker, Spinnaker, etc. There are a lot of softwares that help us create, build, and deploy software. So this is just a fact, right? And we have to deal with this fact. Another fact also to keep in mind is that software is painful. It is unfortunately still painful for a lot of people. It is still surprisingly hard for a lot of developers to actually choose whatever runtime they want to use. Because every single runtime, companies need to make sure it works, it's safe, it doesn't have vulnerabilities, etc., etc. Whenever you want to get something as a developer, you will have to fill in a form. That's just a fact. For at least a vast majority of developers, this is a true fact today. You have to fill in a form, and somebody have to approve your form before you can get that platform or that instance that you need. You will have hard time pushing stuff to production because there is always somebody who will tell you that your push is not approved because it will break production. And if you need a new server, well, surprise, surprise, there is still today people who need 6 weeks to give you a new server. This is actually a true fact in one of my customers I'm working with today, and I'm not going to mention any names, but they are in the financial sector. It takes 6 weeks to get a VM provision. So all of this makes software painful, and it doesn't have to be, because software is changing as we know it. In the past, or it is still also true today, you had to deal with a lot of things, from the bottom layer things of infrastructure, so networking, storage, and servers, all the way to the operating system, the runtime, the application, the data, etc. We try to solve this problem through something called IaaS, infrastructure as a service. And as Rustam said in his talk, serverless doesn't have to be only in the cloud. It's true also for infrastructure service. Infrastructure service is a concept. It's not only valid in cloud environments. It could be used anywhere. It could be used on-premise, where there is a team that will provide an on-premise infrastructure as a service platform that would allow developers to just provision infrastructure on top of it and run their application. Or it can be in the cloud. What's changing about today's way of doing things is the fact that more and more layers are being taken care of by cloud providers or by people, right? So we're getting to a place where even data, runtime, middleware, operating system is actually taken care of for us. We don't have to care about it. And people are using some sort of unified platforms to do that. So the one that would probably jump in mind today is Kubernetes, which allows you to basically abstract away the runtime part from the developer and allow people to just write and deploy applications in a unified way, regardless of what's the infrastructure under it. And that's what people mostly mean by cloud native, right? Again, similar to the fact that infrastructure as a service is a concept, it doesn't have to be only in cloud. Cloud native is also just a concept and a set of best practices to follow. It doesn't have to be only on cloud. You can build cloud native applications on premise as well, right? So then what is cloud native? I'm not going to spend too much time on this one because I think that Rustam have already done a good job explaining it. But basically, I took the definition of the CNCF of the GitHub repository. The link to the GitHub repository is in the comments of this slide. But the pure CNCF definition is, as you see in the screen, I'm not going to read it. I'm just going to read what I highlighted in bold. So from the CNCF perspective, a cloud native application or a cloud native environment can be public or private or hybrid cloud. It is containers based, microservices, and immutable, and it's API based, right? So this is nothing different from what Rustam talked about. Service mesh is actually interesting. I saw it there. It's the first time I look at the CNCF definition, and I think they were a little bit ahead of time in terms of service mesh, adding the service mesh to cloud native. It is a very interesting concept to throw in your environment. You don't have to. But so these are the description of what a cloud native infrastructure could look like. Now, the second paragraph talks about the application itself. What is a cloud native application? A cloud native application runs in a loosely coupled system, which is resilient, manageable, and observable. And where the key word when it comes into how you manage this platform is automation, right? Automation would allow you to deploy frequently, more predictably, with minimum toil your application, right? So this is the pure definition of CNCF. Now, my definition is that a cloud native application or a cloud native platform is any cloud native platform that has these four characteristics. It is cloud native, it is cloud resilient, it is cloud friendly, and it is cloud ready. So what do we mean by this? Cloud native means that it's microservices API first architecture. So that's for the application itself. And to deploy it, we use a DevOps methodology using some CI/CD pipeline with zero downtime when we do updates. So that's cloud native in a nutshell, if you want, from my perspective. It's also cloud resilient, which means it's fault tolerant. It has metrics and logs that we can look at, and we are able to test it and simulate failures, right? Resiliency in cloud is a different concept than resiliency on premise, because cloud platforms in general give you a lot of services that are managed. So your application should be able to take advantage of this managed platform and just let the cloud provider manage my database. I don't want to care about the database. I will let my cloud provider do that for me, or my PubSub queuing system, or my logs and metrics system, or whatever it is, right? And the application itself has to be cloud friendly, which means it follows the 12-factor methodology. 12-factor methodology is a child brain. It's like a set of concepts that a lot of cloud providers got together and wrote. You can check 12-factor methodology in Google, and you will see all the definitions, right? It has to be stateless. Doesn't have to be always stateless. An application always works with data. So ideally, your application is stateless in the sense that the application itself doesn't store data inside its environment, and it depends on an external storage system to do that, right? So that's what we mean by stateless. It doesn't mean that the application itself has to be stateless. It doesn't have data. It just means that it doesn't store. It can cache data inside the environment of that application when the process is running, but the storage part is decoupled, and it talks to an API or to a database or to a queue system in order to fetch and handle data. It has to be horizontally scalable. You know that in order to scale an application, there are technically two ways. You can scale it horizontally, which means adding more instances of the same application, or scale it vertically, which means resizing the instance itself. Vertical scaling almost always means downtime, because it almost always means restarting the application. Horizontal scaling means adding more applications, more instances of the same application, and just putting everything behind database, a load balancer, and letting the load balancer handle that. And ideally, your application should leverage the platform built-in scalability mechanisms, right? What do I mean by that? I mean that, for example, if you're running on something like Google Cloud, you are able to use things like manage instance groups, which take some inputs in terms of the usage to scale your application, or you can scale on top of like custom metrics and stuff like that. Or if you're running on something like Kubernetes, it has its own built-in scalability methodologies. But basically, your application should be able to scale horizontally using whatever the platform offers to do that, which ideally is a native way and not some hacked script that will just add more instances. And then Cloud ready means that your application has dependency on externalized storage and caching. It's self-contained, which means the application has its own all its dependencies in whatever packaging format you're using, and as I said earlier, you are leveraging whatever the platform gives you in terms of services, right? So then, with those in mind, let's dive in. What are the 5 reasons why your application is not cloud native? Your application is not cloud native if the application itself and its infrastructure are not immutable. So immutable is a loosely defined term that means that the application or the infrastructure could be recreated on the spot with minimum impact to your end users, right? And this is a very crucial term, very crucial notion that you have to have in mind in terms of cloud nativeness. An immutable application is basically an application where every single instance could just disappear at any moment in time and come back, and it shouldn't impact the user, right? So that's that for the application itself. Infrastructure immutability means that your infrastructure is highly automated such a way that you can just tear it down and create it again, or create an exact replica in a different region in your cloud provider's infrastructure with minimum manual intervention. And immutability is especially important for cloud native applications and the infrastructure itself for simulating failure and for being able to recover from a disaster, right? And I'm going to talk in detail about these 2 things. Simulating failure in a cloud native environment means I am able to set up my infrastructure, which is used to serve the production traffic, but also in parallel, I'm able to redeploy all my infrastructure, redeploy all my application, and then take down parts of the application and see how the application would behave, right? The only way you can do this in an easy way is if everything is automated. If it's manual, it's going to take time, right? The other thing also that is important here is automation also allows you to test for changes in your dependencies, right? So if we take an example, and just not because I'm wearing the hoodie, but Kubernetes example, Kubernetes as a tool is actually evolving very fast. And one of the best ways to make sure that your application is not going to be impacted when a specific API changes or when something changes in the infrastructure, and here I am explicitly putting in Kubernetes in the infrastructure layer, the best way to do that is being able to simulate that you can set up your infrastructure plus your application in an automated way and test it so that you can catch any regressions or any incompatibilities, right? So a good example that I worked on a lot of projects is being able to deploy my entire infrastructure stack, which is Kubernetes based, plus my entire application, and run some sort of shadow traffic and see if, and do this based on newer versions of the infrastructure, right? So go into the next version, the next available version of, I don't know, Kubernetes, deploy that and make sure my application is deployable, right? So that if an API changes or something like that, I can catch that. And I took the example of Kubernetes here, but it can be anything, right? It can be Docker Swarm, it could be Nomad, it can be Knative, it can be anything, right? So this is immutability in terms of simulating failure. The immutability in terms of recovering from a disaster, that's pretty clear. I have my infrastructure, something goes bad, I am able to just set up everything from scratch, redeploy the application, and give access to the users again to my application or to part of my system with like the minimum amount of downtime possible, right? So that's essentially what immutability means for the infrastructure and the applications in the context of failure, simulating failure, and disaster recovery. Your application is not cloud native if it's aware of its environment. What do we mean by that? I have seen this so many times where the application will have some sort of test case before it starts to say, am I running on a virtual machine or am I running on a container? It's actually a very trouble pattern because it makes your application not portable, because you cannot possibly build into your application all the possible environments in which it will run, right? So, or for example, that your application have hard-coded configurations or hard-coded secrets, which God forbids, that's like a bad thing to do, in its code or in its configuration files, right? Which means that if you want to test a new flag, you have to redeploy basically the whole application, right? So if you really follow, if you go into the 12-factor application patterns, one of the things is that you have to externalize your configuration, and you have to make it available in the environment, which means that the application itself, when it starts, it doesn't care where it runs. It just knows it's going to find a bunch of environment variables to tell it what to do. That could be an environment variable for a password to connect to a database, or an API key to call an API, or it could be just an environment variable that has all the flags that the application needs. Now, in nowadays cloud native world, there is also software available to do feature flags, where your features are available from a remote server, and your application starts and talks to the API of that remote server to say, like, tell me how am I going to behave, right? So that's application aware of its environment. If your application is aware of your environment, it's not cloud native. And I'm just realized I'm actually moving very fast, so I should probably slow down. Your application is not portable. If your application is not portable, it's not cloud native. What do we mean by portable? Means that I can deploy it on my laptop as a developer. I can deploy it in my test stage environment, and in my production environment the same way without having to rebuild it, right? And here we mostly talk about containers, because containers can actually guarantee a high level of portability, but it could be anything, right? It could be your Java application, jar file, but it's part of a highly automated system using some scripting that would make sure that the environment where the application run is always ready for that application to run. As long as your application meets this like loosely defined portability definition, it is cloud native. Now, to be very clear, you should not be too insistent on the idea that your entire infrastructure should be portable. The reason behind this is very simple. It's because you're not going to have the same services across all the platforms where your application would run, whether it's cloud or on-premise. So you might, for example, have access to, I don't know, Aurora database when you're in AWS, but Google Cloud doesn't have that. It has something called Google Cloud databases, Google Cloud SQL, for example. You might have access to, like, I think it's called SQS in AWS, but we don't have something similar in Google Cloud. We have PubSub and we have other tools, right? You're not going to be able to guarantee portability for all your application dependencies, but as long as the application itself is portable, that's already a great thing, because you can always sort of simulate the behavior of certain dependencies using open source tools, right? So that's the third reason why your application is not portable. The fourth reason is your application and its infrastructure are not observable. So observability is a very highly defined term as well, which means beyond monitoring, right? We all know what monitoring means. Monitoring means essentially that your application and your infrastructure expose a certain set of metrics, and that you are able to scrape those metrics, store them, and then plot them on a graph, and you can see how your application is progressing. Observability goes beyond just metrics. It goes also into things like business-defined metrics, not only application and infrastructure metrics. So application and infrastructure metrics are things like memory, CPU, storage, etc., etc. Observability are also things like how many requests my application is processing correctly, how many payments my application is able to do in a minute or in a day or in an hour, how many 400, 500, 600, there is no scale, 400, 500 responses, 300 responses my application is returning, versus how many 200 my application is returning. It is actually using monitoring tools to collect all the metrics and then combine these metrics in a way that can tell you what's the health of your application. That's observability. And observability should be built into the application itself, but also into the infrastructure, right? If your application cannot give you the level of observability you need to be able to say, is my application working or not, beyond monitoring and beyond just simple, I'm going to ping my server to see if it works, then your application is not cloud native. And last but not least, your application and its infrastructure are hard to scale. So scaling your application should not require you to open the tickets to somebody to tell them, please give me more VMs, or please add more instances of my application. Ideally, your application should be able to auto scale, which means it should be able to just add instances of itself in order to keep up with demand, right? And I talked about it earlier, the application should be able to use whatever platforms built in auto scalability mechanisms, right? So your scalability should be automated and it should not be manual. It should not rely on humans. And ideally, your scalability of your application should depend on its traffic patterns. So your application should be able to scale up and down based on the usage, essentially. And with that in mind, I think I am probably on time, too many minutes. I'm happy to take questions or debate you on Twitter. That's my Twitter. You can follow me there.